Welcome back to another episode of Python Programming from Beginner to Programmer. Today we are very excited to have this topic on data analytics using Python's famous libraries called Pandas and Numpy. You might or might not have heard of these names before, but not to worry, we're going to start from scratch. All right, from the basic concept onwards to hopefully the extent that you can start writing short scripts and programs to make things work for you. Now, this is getting to be the part that is very close to our daily business because it's going to deal specifically with data. So we have a couple of agendas, and it's not going to be covered in one video. I'm going to use a whole series of segments of videos to talk about individual aspects of operating the objects and under pandas and how we use these to perform data analysis and data analytics on our sets of data. Now, we begin by understanding the concept, how to think about it. And this part, although it's going to fall into the kind of conservative kind of style of introduction background and stuff like that, I feel that from a lot of feedback from students, when you don't understand how pandas and Python think about data, how they are being represented and processed internally, that means the concept is misaligned, end up you will have a lot of misunderstandings, frustrations, bugs, and all that in subsequent attempts to write programs. So it's very important here that you don't jump and skip this part so that you really have a good understanding. Now, I assure you, is a good understanding doesn't mean it has to take long sessions. It's going to be the barest essentials, the most critical, uh, crystallization of the concepts that I will talk about and refer to, so that you can quickly grasp what pandas and Python are thinking, so that you can always utilize them and in harmony rather than go against them and they do something that you didn't want to and you want to do something and they don't do what you want to do. So this is a critical part, right? So let me just emphasize that try to go through this part and understand the framework concepts first. And the problem is it's not going to be textbook subsections, to 4 level deep, that kind of discussion. So it's going to be quick and dirty, but sufficient enough for you to have a good grasp of what pandas is specifically thinking about. Okay, then we talk about the detailed actions that you can perform, the common things like replace some of the values, the data, fill them, append, delete, make larger composites of data sets, and do some very amazing magic like automatically, or rather smartly and intelligently perform certain changes to the data. And we can do very important activities like filtering. I don't want the whole thing. I would just want certain subsets, right? I want to search, I want to extract, and how do we do all these quickly, right, and smartly. Then there are always this section on errors, because in real life data is very noisy and we have to learn how to see noise in data from the perspective of pandas. Then we can once we have all these basic actions and abilities, we can now talk about higher level goals like analyzing this set of data, right? What are the statistics and stuff like that. And of course we can always perform long-term storage. Yeah, they don't always have to be manually typed in the data. You can store in files, attach to emails, send the results, receive data from various sources, and then perform analysis, right? And basically that is going to start us off. If you have fully understood all this agenda, that is going to start us off, and we can then perform more complicated data analytics from that. So this is just the beginning. Now, to start off, we already have list, tuples, dictionary, right? If you can recall, and sets. These are the more structured and composite data types that allow us to hold many pieces of data. So if we have date of birth, name, address, we can always keep them in a list. And if we have many people having date of birth, name, and address, we can always keep them in a list of lists, right? So if we ask the question, can we use Python alone without NumPy and Pandas? Answer is yes, we can. So then why Pandas and NumPy? And the idea is that we want certain efficiency. All right, efficiency is not just in terms of storage in memory, storage in hard disk. We know that the cost per terabyte is coming down. So why do we need to save space? Well, the idea is that when the cost goes down, you have more and more data. You have video data. You have a lot more data from sensors, and so to store them is going to be cheaper, but the volume is also escalating. And then to get meaning out of it, and that's the analytics part. Like we need to find the average, find the total. It becomes very slow when we allow the list to have different kinds of objects like integer, float, string, or a string float or something like that, or string class object and list and dictionary and so on. So if we have a mix of data types, computers for all languages, whether it's C, C++ or whatever, including Python, will slow down because it has to look at this object and say, what type are you? Then I have to activate the relevant functions to understand you. So if it has to do that for every piece, then it's very slow, unnecessarily slow when, for example, you have 100 by 100 matrix of integers. Maybe that represents a little thumbnail. Maybe that represents certain coefficient sets that you are going to use in your mathematical calculations and so on. Yeah, so in those cases, Python's basic structured type like class or list, they become painfully uh, inadequate because they are very, very slow, right? So in terms of efficiency, we want something that is more adaptive to our business applications. Business simply just means our daily lives, right? So your business can be in science, but that's the daily usage of data. And in most business settings, including personal lives, we will have data that include fields like name, age, and salary. And name is a string, age is probably integer, salary, well, because the number can get large, we can use float because it may be subjected to other percentage calculations, so we use float. So it's a mix of types, and as we said before, computers will slow down by a lot, so it's like by 5 times, by 10 times. And if you're processing 100 pieces of data, that's going to be unnoticeable. But we're talking about huge sets of data, like 1 giga set of data records, and then cross calculating, cross computing, and that is really massive, right? So we want something quicker and yet having the flexibility to allow us to represent and compute such data. And the answer comes with pandas. Okay, so pandas and numpy, they provide efficiency and also flexibility. So it's probably not as fast as if you have to write them purely in C or C++, but if you do that, you lack all the flexibility that Python offers. So numpy and pandas together, they give us this whole realm of sort of kind of a best of both worlds. We are both efficient and we are also enjoying various language flexibility mechanisms that Python offers. So in short, NumPy is going to assume one data type only for all its internal data pieces. So if we have a vector of 100 cells, then NumPy will basically assume that all the cells are integer, all the cells are floating points, all the cells are strings. And if we have a matrix table of numbers, then they're all integers, or else they're all floats. So it makes it very uniform, homogeneous in types, and therefore very efficient. However, NumPy addresses more at the basic level, and that is great for scientific calculations because there are a lot of mathematics and that require such such a efficient representation. Even for matrix, all are integer, all are floats, makes it very fast for calculations. But in data records, in business usage, and by business I also mean personal lives, and small business, large business, we will have a mix of types, right? So we have string, integer, float, for example. um so that is going to have non-homogeneous type if we go by row. But if we stack it up, that means we have a lot of people having name, age, and salary, then the column becomes uniform in type. And that's where Pandas comes in. Pandas offers us a 2 by 2 kind of table structure. All right. And also, I mean, in the sort of singular case, we have a 1 by n or n by 1 column vector or row vector. So Pandas allows us to have that, where each column has the same type, but different columns may have different types. That's the whole flexibility that Pandas adds. So that is by no means trivial, by no means incrementally adding a little bit of feature, right? So allowing different columns to have different types makes a lot of sense to us. So, but that also means there's a lot more code needed for various kinds of things. Remember, we were talking about how to replace, compose, extract, filter, and all that. So we need a whole bunch of codes to understand this efficient structure, right? And Pandas is that layer.